Welcome, everyone. The APA Standards and Codes Council is pleased to sponsor this webinar today. Please note that today's call is being recorded. All participant lines are muted during this broadcast. Today's presentation will last 60 minutes and include a Q&A session. You can queue up a question for us at any time during the presentation. To ask a question, simply type it in the chat box area in the lower right side of your screen and click Send. Should we run out of time for our Q&A, the remaining questions will be sent to the presenter and the answers will be posted on the website along with the recording and presentation slide. This presentation is offering AIA continuing learning credits and APA certificates of completion. Please contact Phil with your AIA member number for the CLUs. If you did not sign up to receive the APA certificate of completion during registration, please contact me at Billie, B-I-L-L-I-E, @apa.org. It is my pleasure to now turn the presentation over to Phil.
Thank you very much, Billie. Good afternoon, everybody. I really appreciate you turning in for the presentation. My name is Phil Shimoleski. I'm the National Sales Manager for Merchant & Evans, a high-performance standing seam metal roofing company. We're located and have been located for well over 100 years in suburban Philadelphia. We're actually in Burlington, New Jersey right now. That's our corporate headquarters and one of our production facilities. We also have production capabilities in Atlanta and the Sacramento area in California. My background, civil engineer from the University of Connecticut. Have about 25 years in the construction industry, been a real estate developer, been a general contractor, and I've also been in a role similar to I have now as a sales manager for building construction products. So that's sort of a little background on me and my firm and what we're all about. I'm going to dig right into the presentation now, and we start with one of my most favorite photos that we have. This is the Ryan Walter Athletic Performance Center for Northwestern University in Evanston, Illinois. Not only is it a tremendous building that has our zip rib product, but it's located in a great spot, right on Lake Michigan in Evanston, which is north of Chicago. You would take Lakeshore Drive right down to the city in the background there. So it's just a great project, and you'll see a little bit. I'll show you one of the pages from the shop drawings that were accomplished to create that very, very challenging metal roof that you see there. This is an AIA accredited presentation. It does come with HSW accreditation. As you can see at the bottom there, if you are an AIA member and you need credit, please email adminassist, ADMINASST, @ziprib.com. You'll also see later my email address, which is simply phil@ziprib.com. Because of my last name, I'm the only person here allowed to just go with their first name because they didn't want my email address to be so long. So you can email me also, and I'll make sure that you get the credit inputted for you. Course description. In essence, we'll teach you how to design and specify a high-performance standing seam metal roof, which I will say is a true contradiction to just any old standing seam metal roof, and you'll see why. We'll take you through the design process. When we're done, I'll talk to you a little bit about a couple of steps you can do in specifying your metal roof that are not going to add significant costs, but are going to give you an outstanding system. As I said before, this is not only a learning unit, but it is HSW accredited. And here are our learning objectives. In essence, we'll talk about the materials of construction and the advantages therein. We'll talk a little bit about testing, a little bit of the drier area of the presentation, so I won't spend too much time on that, but I'll give you a little background as to what goes into that. We'll talk about the functional performance characteristics of a high-performance roofing system and why it's different, and then we'll talk about coating systems as well. Now, I just broke out some stats on just one segment of the marketplace. I know we have people involved in education facilities planning from kindergarten through college, but just the college arena alone is very, very hot, as I know is the elementary and high school market. $100 billion in 2017 was spent on school construction products nationally. Largest one-year increase in almost a decade. New buildings, rehabs, replacements, but renovations was a big, big part of that. Renovation and modernization was maybe the largest component. The top 10 states for college construction, understandably, it pretty much follows the top 10 states in terms of population, at least initially. Number 1, Texas, or number 1, California. Number 2, Texas. Number 3, New York. Now, the 4th largest state in terms of population is now Florida. And as you can see, it doesn't even show up on the top 10 list. Florida is actually number 15 in terms of university construction. I think a reason for that may be that a lot of the universities are newer down there and they're maybe not undergoing the renovation, because there's certainly an influx of residents to Florida, and there's certainly a need for college facilities in the arena there. The surprise, which is nowhere near the top 10 list for population, is Massachusetts. And again, this is colleges and universities. I'm saying it's a surprise, but it's not a surprise, right? If you think about the Boston area and how many great institutions are in that arena, it's no surprise that Massachusetts jumpstarts a lot of much larger states to get toward the top of this list. We subscribe to Dodge Nude Services, formerly McGraw-Hill, but now it's just known as Dodge. At the moment, and again, I'm just talking the college and university arena, but I will tell you, I looked at these numbers for elementary and high school. There are 2,889 projects in development, and these are only projects with a budget of $10 million or more. Together, those projects total over $148 billion. And again, the stats for pre-college, high school, elementary school are comparable. So if you're all feeling pretty busy out there, here's an explanation as to why you're feeling so busy. There's a lot going on. What are your biggest challenges? And I'm not breaking any barriers for anybody here. You know what these are. Availability of construction labor. We just don't have the talented people, the tradespeople that we need to fill all the roles. Budget is always an issue. Even if you've got a nice endowment or you've got nice financing, the budget always very important. Consistency with current campus aesthetics. We want to maybe build modern buildings, but maybe our campuses are older, turn of the century, meaning the last century, or maybe they're those post-World War II buildings that are not really that attractive. So how do we make all this happen aesthetically to start to migrate our campuses to where we want them to be? Preparing for possible future needs. Our schooling population is growing in many, many parts of the country. How do we plan for that? We don't want to be buildings that when we finish the school, we've got temporary structures needed almost immediately, which I spent a good part of the last couple of decades down in Florida, and that was basically what it was. You'd finish the school, and the next year you've got temporary classrooms again on site. Limited availability of space. I mentioned I went to the University of Connecticut. It was kind of a rural open campus when I went there. I recently went up to Storrs, Connecticut, and it's a crowded, very congested campus, and they do have a lot of acreage, but we're running out of room. And then, of course, you're working within a school, you're working with a university campus. What's the effect on your daily campus life and procedures? So now I'm going to dig into the meat of the presentation. What is a high-performance standing seam metal roof? Number one, it's designed with concealed clips that eliminate fastener penetration through the surface. Number two, allows for unrestricted panel movement. Now, this is really important because you're going to see some metal roof panels that are very, very long. I'm going to show you a project at Raleigh-Durham International Airport where we had metal panels that were 460 feet long, and we had to design our clips to be able to withstand 5 inches of thermal movement in a given day. you've got a lot of forces acting on these roofs. Atmospheric corrosion, hail, walking loads, hurricane force winds. We need to be able to produce them from various metal types to meet your corrosion requirements, maybe to meet your aesthetic requirements. We need to test them to make sure they're performed as designed. And I know we've got some architects and engineers on this call, or folks that hire architects and engineers. You want to have your architects to have design freedom to accomplish what you want in terms of functionality and aesthetics on a project. So this slide begs the question, is this your perception of metal roofing? And hopefully it isn't, but to some people it possibly is. Well, why not this? And these are a couple of our more dynamic projects. On the top is the Sacramento International Airport in Sacramento, California. And then the lower one is the project we did in Cupertino, California. It's the Apple Computer headquarters. What are some of the things we do to ensure that we have a high performance standing seam metal roof? Number one, when you get to longer panels, often over 40 feet, shipping becomes an issue. Now we can ship longer trucks, but sometimes they can't navigate onto the job site. So what do? We job site roll the panels. But a very important distinction is that you don't want to allow contractor-owned job site roll forming equipment with a contractor operating rolling these panels, because you'll get what you see on the left there. A little trailer in the back of a truck with 6 to 9 sets of tooling, as opposed to a manufacturer bringing their equipment on site where you'll have 18 sets of tooling, exactly like we have in our factory. You want a performance system that can be zipped as well as unzipped, meaning that the way we seam this product is with a zipping machine like you see there, but you also want it to be unzipped in case of damage or a need to pull up one of these panels. That zipper can go upslope and downslope. You can go to a very, very low slope with a high performance system. Typically, if you don't have a system where you're comfortable of your weather tightness, you're going to avoid low slope environments. Not the issue with a high performance system. 1/4 inch and 12 is the minimum slope, which is practically flat, as you know. We're almost always installed over solid deck, but it can theoretically be installed over open framing. We're almost always using underlayment, but theoretically it could work without underlayment. We can do continuous lengths up to 460 feet, and that really is only limited by how much steel or aluminum or metal is on the roll that is being fed in to produce the panels. You have to have a structure.
We have a question coming in.
Okay.
We have someone who has asked if you could talk about solutions for preventing oil canning of the panels.
Okay, we will actually. That's a couple slides going forward. But it's a very important topic.
And another question came in, what is the smallest diameter an aluminum metal roof can be rolled?
Okay. The second one I can kind of answer a little more generally. It's going to depend on the gauge and other factors, but if somebody has a specific situation they're looking at, they can email me. But you're typically going to see a number, I'm going to say 20 footish, less plus or minus, but please email me and I'll give you my email address at the end if you've got a specific circumstance, because we need to know metal type and gauge and that kind of stuff. And I'll talk about the oil canning in just a couple of slides. High performance systems are manufactured as a system, meaning that we can produce just about any component in the plant. If you work with a parts and pieces manufacturer, as we might call it, they employ factory workers and not technicians, maximum 40-foot panels that have end laps and require stitch screws. Non-standard flashings are fabricated in the field. I think the picture at the right really shows you that component. They're segmented, kind of a dinosaur look, as opposed to this look. On the right, you see a curved roof with an end flashing And look how nice that is. That's designed on our shop drawings and manufactured in our plant. Trained craftsmen are doing this work, capable of providing continuous full-length panels up to 460 feet. Flashing is custom formed, and we utilize a two-piece closure system. Now, one of the things that we really believe in is a two-piece clip, and this again is getting to that thermal movement issue. If you've got a one-piece clip and it's bolted to your substrate, really that clip and that panel need to take all the thermal movement. It causes kind of a bind and slip condition. We have a two-piece system that is, again, bolted to the substrate, but that clip on the top is allowed to move and migrate along with the thermal movement, so that you've got nothing happening here that's going to cause that bind and slip component. Now, here's the issue of oil canning, and there are a couple of ways to avoid that, because that's the kiss of death, right? If you're an architect and you designed a roof and your owner goes out there and you see what's on the left, you've got a very, very unhappy customer. And if you're an owner and that's your roof, you've probably got a very unhappy school board or board of directors. One of the things is work with heavy gauge materials. I see time and time again, 24 gauge specified. You can, quote unquote, get away with a 24 gauge metal, but if we're in the steel world for the second, I would go to a 22 gauge or possibly a 20 gauge. I think it's worth your money to get a heavier gauge. Tension leveling of coil to reduce the stresses in the coil. This is a very technical process that I'm not even going to try to explain to you, but it's basically functioning our steel before it goes through the rollers so that it's tension leveled, so that those 18 sets of rollers can form the panel without injecting a lot of extra stresses. And again, use of multi-stage roll formers, those 18 sets of rollers as opposed to the 6 to the 8 that some contractor has convinced you he can roll his own panels will have on the job site. Longitudinal stiffening ribs. We put a pencil rib, usually 2 of them in the panel, which will also resist oil canning, and the 2-piece clip as opposed to the 1-piece clip again. So if you do these things, you will not have oil canning. Let's talk a little bit about testing here. There are 3 standards for testing. The first is Underwriters Lab. That is UL 580, and you often hear about a UL rating of, say, Class 90 or Class 60 or Class 30. So if you have a Class 90, you qualify for a Class 60 specification or a Class 30. We test the roof assembly as a whole, as you can see there. We use 2 methods, basically. Static pressure, which is pressure set for a predetermined length of time and released, or oscillating pressure, where the chamber is pressurized, depressurized with increasing increments until the max pressure is met or failure occurs to establish your class ranking. The ASTM test is E1592. We've got a larger chamber panel here. We've got unrestricted end attachments, which allow for more accurate in-service test results, meaning this test here more accurately represents what's happening in the field. The test is run to ultimate failure of the panel system. And again, it's tested until it basically maxes out. And then the factory mutual FM4471. I'm going to talk about that a little bit more here in a second, because there's a couple of different kinds of components that go into that. In the first 2 tests, though, ASTM E1592 and UL 580, here's basically what your panels look at if you're looking through a cross-section. In the top is the normal unloaded condition. B is a positive pressure, meaning a pressure pushing down on the panel. That's typically not what we get, for example, in a hurricane. In a hurricane, you end up with negative pressure, which is basically that panel being sucked upward. D and E show you failure conditions. They can happen one of 2 ways, rib rotation or rib spread. Now, let's talk a little bit more about the FM testing and how we design for wind loads. Because when we design for wind loads, we need to talk about different areas of the roofing system. But first, the FM testing. Here are some of the variables involved. They're testing for fire, for wind, for foot traffic, for hail damage. The variables they look at is exposure factor, the potential percentage of loss of the use of the structure if a specific threat is realized. An example of this would be if a building was in an area where fires might occur. This may raise the exposure factor if we had a potential failure. Importance factor. That's how catastrophic is it if something happens. So for instance, your buildings where you've got students involved are very, very high importance factors. A warehouse or a machine storage facility would have less of an importance factor. The topographic factor takes into consideration the physical features of the surrounding areas. And again, an example of this would be a low-lying area that would be susceptible to flooding. Roof slope, which we talked about, it's the measurement of vertical change in a 12-inch longitudinal change, how the roof is designed, and what the mean roof height is. If you took all of the roof surfaces, what is the actual mean roof height? Now, here are some of the factors we put into actually designing a roof system for a specific wind load. What's the roof type? What's the slope? What's the eave height? The exposure factor we talked about previously. The wind speed that we're designing for. And then the risk category, which we talked about that a little bit. Low risk to human life is a 1. Up to 4 is an essential building, like government building. Your facilities would be 4. In this example that we're doing here, we're talking about a category 3. Now, you don't get one singular design pressure because your roof is really looked at in 3 different components. The center of your roof field is area 1, which can be designed for a lower wind velocity factor. The eaves are your second most susceptible areas to wind destruction. They're designed for a higher wind load. And then the corners, where the eaves on 2 sides meet, is your highest and your most high-risk area. So in this example, you can see we go from a 35 PSF all the way out to a 90 in zone 3. Now let's talk a little bit about selection of materials. We can do high-performance roofing panel systems in a wide range of materials. So we talked a bit before about your architects having the flexibility to accomplish what you want. The 5 most common types of materials that we get into high-performance systems are galvalume, aluminum, zinc, copper, and stainless steel. And I'll talk just a little bit about each of them. Galvalume is ostensibly a value solution. It is your cheapest approach to putting together a metal roof. So the advantage is a low cost. The disadvantage is it's susceptible to corrosion, and it's hard to handle in the field. It's a heavier material. Another disadvantage, which if you think about it is very important, all those other materials that I talked to before were homogeneous materials providing the corrosion resistance. So for instance, aluminum, if you cut through an aluminum roofing panel, you've got aluminum all the way through. If you cut through a galvanized steel or a galvalume steel, you've now cut through your coating and you've got an exposed area that is not coated. That needs to be treated. Generally, I'm not a fan of galvalume roofing systems. You can move to an aluminum system for a slightly higher material cost that is often completely ameliorated by the savings in labor, because suddenly the contractor needs fewer people on the job site to handle a given panel. But here we can see some extreme cases of what happens with galvalume roofs, particularly if they're put in a high corrosion area. That China King, which does not have a high-performance standing seam metal roof system, 5 miles from the seacoast, so not right on the water, but certainly a distance away. In 3 years old, you're starting to see some corrosion and pitting. To the right, you've got an uncoated steel panel, and you can see what quickly happens to that. Now, let's move to the other end of the spectrum, and I'm going to talk about aluminum last in this group. Copper and zinc, these are beautiful materials, and they've got a lot of benefits. I will tell you their material cost is expensive. We've done a lot of zinc roofing, particularly some airports who've had some very good budget dollars have used zinc, and it's a great material. It's got wonderful aesthetics, long life expectancy, must be on a higher solid substrate, and it's very, very high cost material-wise. But again, depending on budget and aesthetics, what you're trying to achieve, we do a number of projects in both of these. And there's a zinc roofing system. Very beautiful, very unique coloration, no coating on that, just kind of runs with its own natural material. But the sweet spot, I believe, is aluminum. Here you've got a real durable material, slightly more expensive than galvalume, but again, if I can handle a certain size panel with 3 laborers instead of 4, all of a sudden I'm saving some money on the site, and I'm in much better shape economically than I even thought. Aluminum is incredibly corrosion resistant, and it's lightweight, so it's very easy to utilize to get up on the roof system. Here's a project that you could see. In this particular project, they were looking for a patinaed copper look. So we can achieve a copper look with a painted panel. We can achieve a patinaed copper look with a painted panel. And this is built right smack on the beach, and that will last for decades and decades. You've got limitless possibilities when you use a high-performance system. It really leaves nothing that your architect cannot do in terms of matching their vision and your vision. We can curve panels. We can make them concave. We can make them convex. We can taper long length panels. We can build domes with custom framing systems, and we can operate on coastal environments. Curving, concave and convex. This is in Orlando, Florida. You can see it from I-4. I was just down there last week, in fact, and drove right past it. It is the Lynx Central Bus Station for Orlando, Florida. This is one of my favorite projects. I've mentioned it before in this presentation. This is the Raleigh-Durham International Airport. Concave and convex roof design. But again, the beauty here is that was 460 lineal feet of panel. That's one panel going up and over that entire roof system. Shot from the ground up onto the roof system and designed to handle the thermal movement of 5 inches that was expected on a potential given daily basis. In curving, again, this is where we started this presentation at the Northwestern University Ryan Walter Athletic Center that basically has that sort of domed roof that is all standing seam metal roof panels. We can do free-span canopies up to about 15 feet, meaning that you don't need structural members. The panel is sufficient structurally to span that distance. And I know we do a lot of canopies in school systems, particularly high school and elementary, particularly in warmer areas. And here's a way that you can do it without any structural system unless you're getting above 15 feet or so. One of my favorite pictures, this is in Newport News, Virginia. It is the Christopher Newport University, and that is not a copper dome. That is a painted aluminum dome, and that will look beautiful like that for decades and decades to come. Another roofing system here, Centenary College, the Lackland Center, and a beautiful finished metal dome system. And we talked about coastal environment. Well, this is Jimmy Buffett's Margaritaville Bar and Grill, right on the water in Atlantic City, designed with an aluminum roof system, and we have no concern for its durability in about as aggressive an environment as you can possibly imagine. So let me just quickly change presentations on you. That's the formal AIA presentation, and I want to give you a quick overview as to how to turn this into a functional specification so that you can employ it on a project. And again, I start with this because that's my favorite picture. There are really 6 things you can do to enhance your metal roofing spec. You can do a lot of other stuff, but if you do this 6 things, you're gonna have a great spec and get a great project. The low-hanging fruit is don't allow contractor-owned job site rolling equipment. You don't want somebody coming in with a little trailer on the back of his pickup truck rolling your panels. Number 2, build in resistance to oil canning. Somebody brought up the question, and rightfully so. It's a big issue. There should be no transverse seams or splices, panels continuous to their full length. We have the ability to do that. Use a minimum .040 aluminum for durability. If your budget affords it, an 050 is even better. And use a minimum seam height of 2.5 inches. And, you know, last is selfish. Use Merchant & Evans zip rib as your basis of design. But if you do 1 through 5, I'm very happy with the spec because you've got a high quality spec, and that's where I like to compete. So we talked about that.
We have another question coming in. Can you discuss material selection and painting for hail resistance?
Okay. The coatings that we design and operate are all designed to be hail resistant. So if you come in with a 2-coat Kynar finish, which would be one of our typicals on one of our panels, we have a system that will withstand hail, and our finish will have a minimum 20-year warranty, which is typically what we see specified. So back to the slide here. We saw this already, but this is the low-hanging fruit, as I call it. Don't allow what's happening on the left. Build-in resistance to oil canning. Going back to our other question. Heavier gauge material. If you're in steel, go to a 20-gauge steel. Aluminum 040. Tension level your coils. Call for that in your specification. Use of multi-stage roll formers. Call for a minimum number of roll formers in your specification, and we'll help you do that. Pick a panel with a longitudinal stiffing rib and call for a 2-piece concealed clip. And again, bad and good. No transverse seams or splices. There's no excuse with the technology today and the number of manufacturers that can roll form long panels to have seams and splices on a roof system. And here again is the Raleigh-Durham Airport. Use aluminum. Again, that's low-hanging fruit to me. Not a big economic jump, but it gives you low cost with incredible corrosion resistance and a much easier product to handle in the field.
Phil, we have another question coming in.
Okay.
What standard should the specification reference for the finish, AAMA 2605, or are there other standards we can reference to get the fluoropolymer finish?
Yeah, I can get that to you, and I can even get you a sample spec. So who's ever asking that, I would say send me an email to phil@ziprib.com, which you'll see on the screen in a little bit, and I'll get you the actual specification verbiage. Another component here is a tall seam height minimum. And I mentioned this for panel stiffness. I mentioned this for keeping the water between the seams. But I'll tell you, it was explained to me very simply that the panels that are 2.5 inches above, if you put this requirement in your spec, you're going to drive out all the low-end manufacturers. The high-end manufacturers have an ability to do a 2.5-inch seam, and suddenly you've turned your spec from a low-end car to a Mercedes-Benz. And again, those are the 6 attributes that you want to incorporate into your spec. And if anybody wants this, again, shoot me an email and I'll get it back to you. I'm going to go back to our other presentation, and I'm going to finish with just some projects of ours that are located in college and university settings.
Phil, before we do that, we have one more quick question for you.
Sure.
Talk about how the long panels for projects like the Raleigh-Durham Airport were handled from factory to site installation.
Okay. Well, what happens on a long panel is we literally send the roll forming equipment to the job site. When we also send with it the coils of steel. The contractor will forklift the coils onto our roll former. We will have technicians on the site who will perform the roll forming, and as the panels are shot out onto the roof or onto the ground near the roof, the contractor's employees handle that. So it can be done in a couple of ways. You can have the equipment on the ground, and you're basically setting up a production facility on the ground, and then your panels are hoisted to the roof. What we more often see is what we call a tilt trailer, where our roll former is tilted so that the steel or aluminum is loaded in, the panels are formed, and they're literally shot straight up onto the roof where the crews will accept them and move them onto the roof system. We've got other applications, and often this is where you've got real tight constraints. We're looking at a project that I think we're going to get at LaGuardia Airport where it's really, really tight conditions. And what we're looking to do there is literally hoist the roll former in the air on a crane, tether it down, and produce the panels with remote controls. We've also built scaffolding to hold the roll former and then shoot the panels directly on the roof. We've also produced the panels on the roof. So again, set up a production facility on the roof. So those are some of the ways we handle it, and we'll design and develop a logistics plan for every specific project. So this is what I call the pretty picture part of the project, which is just to give you some really nice ideas as to what you can do with this stuff. This is that Christopher Newport University. A couple of pictures on the lower right show the construction, and the picture in the upper right shows that this is an entire quadrangle centerpiece of the university, and that one sort of signature dome is not the only one. They've got other domes that we constructed metal roofs on to make this a nice project.
Phil,
Calvin,
we have a question about the Raleigh-Durham Airport, and they'd like to know if that was 20-gauge stainless steel.
Yes, I believe it is.
Okay. And we have someone else asking how to deal with snow catch clips.
Okay, that's a good question. You know, we have systems that go on the roof to prevent ice and snow from slipping off. We use a special clip called an S5 clip. That's not a generic name. That's actually the most prominent manufacturer. And snow guards are actually installed strategically on the roof so that you don't have that slipping of ice and snow creating an environmental hazard. And we'll help you in your design to figure out where those go. And we don't actually make the snow guard system, but we can bring in a manufacturer to help design that. Okay, here's a system. You know, we think of a roofing system, we think of a big building. Well, here was a pedestrian walkway that literally used metal roofing to create a nice architectural look, but also find a good structural and practical solution to this overpass. If we've got any Nittany Lions in the group, here's the multi-sport facility section, Center and State College, PA. Pretty simple roof, but a nice, you know, concave design, curved roof system, real clean. Brookhaven National Lab in Upton, New York. This looks a lot like the Apple computer facility, actually, with the donut shape around it. A lot of metal roofing panel there. My alma mater, the University of Connecticut, Avery Point campus. I show this not so much for the roof itself, but a lot of the trim and fascia and different accessories that really needed to be developed for a nice, clean, completely comprehensive roofing system. University of Delaware Gore Hall. What's neat about this is that trim you see there is actually constructed of metal roofing. So while it kind of looks like it might be a wood trim, that is really a metal fabrication by our people that can be assembled in the field to provide a nice, really weather-resistant look. And this is back to my favorite, the Northwestern University project. And what's kind of cool here is there's a picture from the inside, so you can see what the football players are enjoying while they're practicing. And on the upper right is one of our shop drawings. And we have a guy on staff here that just has a brilliant mind in terms of thinking in 3D. And he loves these kind of challenges. And this was probably one of the more challenging shop drawing sets for us to produce. So other iconic projects that, you know, some we've talked about already. On the right there is the New Jersey Bar Association. A pretty simple building, but just very attractive, so I like to include it. Bottom left is LAX. If you've ever flown into Los Angeles International Airport, you know the Bradley Terminal, and those were all roofing panels that were shot directly onto that roof. We're currently on the airport right now building the roofing system for the Mid-Concourse Terminal.
Phil, we have another quick question. What are the typical maintenance requirements for an HPSS-MR?
The typical maintenance requirements would be, you know, you're going to want to pressure wash the roof occasionally just for aesthetics. Other than that, the roof is designed to maintain its waterproofness. It is designed to maintain its finish. You probably want to set up an inspection schedule to go up there and see if there has been any damage from a tree limb or something hitting the roof. But really, you shouldn't require much maintenance other than pressure washing the roof. On the right here is the Curry Dinosaur Museum in Alberta, Canada. Standing seam metal roof that literally extends all the way to the ground to provide a very, very unique aesthetic look. So that concludes my presentation. My email address, I thought it was up here, but it actually isn't, is simply Phil, P-H-I-L, @ziprib.com. No dot or space in ziprib, just ziprib.com, as you can see on the website there. So I thank you. I would take any additional questions that y'all might have.
Oh, we have questions coming in. Oh, we just got a very nice thank you. Great information.
That's good. I appreciate it. I enjoyed chatting with you all today.
Again, if anyone has any questions, please type them in our chat box and we'll get Phil to answer them for you. Okay, what is a square foot cost?
Varies greatly depending on your design. You know, I've seen them for $2 a square foot for the basic panel on up to 6 and 8. We did a project with an exotic material that went way beyond that. It's a very, very exotic material recently. But, you know, in general, you're going to often see a quote from us where the panel itself might be a $3 number. But again, I've seen less than that. But it depends on gauge and material and other factors.
What is the cost compared to single ply roofs?
You know, I don't handle single ply roofs, so I couldn't answer that specifically. I know it's going to be more expensive, but it's a whole different application because a single ply is a flat roof, but we would definitely be more expensive.
Okay. And Phil, would you please spell your last name for everyone? Okay.
If you got your pencil ready, it is C-H-M, C like in cat, H-M, yes, 3 consonants in a row, I-E-L-E-S-K-I.
Okay.
And again, I will need everybody's AIA number who wants to receive credit for this. So just send me an email at phil@ziprib.com. If perchance you want to chat on the phone, my cell phone number is 856-777-4849. Or if you missed that, our office number is right on your screen. We have representatives all over North America. They're technical reps. They really know what they're doing. And if you call that office number, if you want to speak to somebody locally, they'll get you in touch.
Okay. Do you have any special requirements for high snow areas?
Just, of course, that would be factored into your structural design, number one, and number two, an appropriate snow guard system.
And do you have a panel finish warranty?
We do. We do, and that's typically spelled out in the specification, and it's often for a 20-year period.
Okay. And would you be able to give someone a qualified contractor in a particular state?
Yeah, absolutely. That's a good question. We actually certify our contractors. So we have certified contractors in every state. And if you're in design and you need somebody to provide budgets, they're usually very helpful with that. We've had contractors bid on our projects who are not certified contractors, but we will tentatively qualify them to bid based on their background and references and so forth. But the requirement would be, before we let them actually install the roof, that they attend one of our ZipRib schools, which we hold 4 times per year.
Okay. So if someone would contact you, you would be able to give them the contractor in a
Yes.
particular state. Okay.
Yes, absolutely.
Go ahead.
We know the capabilities of the roofing contractors very well, and particularly our individuals in any given regional market can give you a very candid assessment of who their best roofers are.
Okay, our next question is the material suitable to retrofit an existing flat roof?
Yeah, there's actually systems that are available in the market that do that. We did an armory right here in Cherry Hill, New Jersey. It was a National Guard armory. It was a flat roof. We have manufacturing partners who build up the structural system to be able to accept the panels. And it's kind of a nice approach because you now convert your flat building, which is probably less aesthetically appealing, into a building with a lot of aesthetic appeal. And then you've got a metal roofing system which will last you. I mean, we talk in terms of the warranties of 20 and 30 years, but the metal roofing system should last 40 years and beyond. But yeah, if you've got an application like that, we've got vendors we work with that build the structural framing systems to do that. It's quite common.
All right. Is this material typically installed over an existing roofing, or do you have to tear the original roofing off?
It actually can be installed over existing roofing. Depending on what's going on, we'll make a recommendation. In some cases, if there are issues with the substrate, they'll take the roofing system off, replace the substrate materials, replace the insulation, and just put a new roof on. In some cases, we'll re-roof an existing roof, where they leave the roof in place, particularly if there's a metal roof. There's a system that just clips right on top of that, and then we just install the new roofing system right above. So yeah, I'd say 90% of our projects are new roofs, but we do have a good percentage that are re-roofs.
Okay. And I believe you've answered this question before, but if not, someone would like to know the warranty and use of snow and ice shield.
Yeah. Okay. So you're talking about the underlayment, I believe, and what we do is we provide what's called a weather tightness warranty. And when we're providing that weather tightness warranty, we have a specific underlayment or ice and snow shield, or water and ice shield is what it would be called, that goes underneath our panel. We know this underlayment, we trust it, and so we require that for our weather tightness warranty. And then the warranty is all comprehensive. It's going to be weather tight. So you're not worrying about whether it was my underlayment that failed or my roof panel that failed. Our system acts as an integral component to provide the weather tightness.
Okay. How does the coating hold up to high heat areas?
Not an issue. Not an issue. We've done projects in the desert states. We've done a lot of work in Texas, and I lived in Texas, and I've gone through those periods where it was 104 degrees and humid every day, and that's not an issue with our coating systems.
Okay. Someone would like to know if you have any project references in southern climate like Gulf Coast, Texas.
Yes, shoot me an email, please, at phil@ziprib.com, and we'll get you some local projects out of our archives.
Okay, we have some very specific questions here that I will forward on to Phil for him to answer privately. And just a quick question about, have you done any projects in Hawaii?
We have. I can't tell you specifically where. It was before my time. I've only been with the company for a year, but I know we have worked in Hawaii. We recently finished a project in the Cayman Islands. We've sent our equipment over to Doha, Qatar, and we've built a roofing system on the Hamad International Airport over there. But we have worked in Hawaii and Alaska as well.
Okay, well, if we have no further questions for Phil, I'd like to thank you very much for your presentation today. And I'd like to thank all of those who are on the line and attended, and please keep checking our website for our monthly webinars. Again, thank you very much for your time, and everyone have a great afternoon.
Thank you, Billy.
You're welcome. Bye-bye now.